Hello friends, grab your coffee, grab your cookie, and keep both far away from any copper grinding bench, because today we are talking about copper dust. Yes, the dust that looks like a reddish-brown powder, smells metallic, stains everything it touches, and in its fine form can behave like a combustible metal regulated under NFPA 484. My name is Michael Klepik, and for 15 years I have been designing dust collection systems for metal finishing, machining, welding prep, foundries, and recycling facilities. Let me explain why copper dust is not as harmless as it looks. What copper dust really is. Technical description. Copper dust forms when copper or copper alloys, such as brass and bronze, are cut, drilled, polished, ground, filed, cast, or machined. Technically, first, particle size ranges from 1 micron to 200 microns. Second, airborne fractions typically fall between 1 and 30 microns. Third, bulk density is high, from 4,000 to 9,000 kilograms per cubic meter, depending on alloy and oxidation. Fourth, dust contains copper metal, copper oxide, and possibly alloying elements such as zinc or tin. Fifth, copper dust is electrically conductive and can cause short circuits when airborne. Copper dust is heavy, reactive, and electrically dangerous. Where copper dust is generated. Copper dust is common in many industries. First, grinding, polishing, and buffing copper parts. Second, CNC machining, drilling, and turning of copper alloys. Third, electrical connector and bus bar manufacturing. Fourth, casting cleanup, fettling, and deburring. Fifth, recycling and shredding of copper wiring or scrap. Sixth, brass and bronze fabrication. Anywhere copper is shaped or finished, dust appears. Why copper dust is dangerous? Copper dust presents several hazards. First, fine copper particles can ignite under certain NFPA 484 conditions. Second, fresh copper dust oxidizes rapidly, producing heat. Third, conductive dust can short out electrical panels and equipment. Fourth, copper oxide particles irritate the lungs and sinuses. Fifth, dust layers contribute to secondary deflagration events. Sixth, copper dust stains and contaminates nearby production lines. Copper is safe as a solid, but a completely different material as dust. Combustibility and oxidation behavior. Copper dust is not as reactive as magnesium or aluminum, but it is still classified under NFPA 484 as a potentially combustible metal when finely divided. Here is why. First, particle sizes below 50 microns ignite more easily because of high surface area. Second, fine dust oxidizes rapidly, especially in dry, oxygen-rich environments. Third, oil-contaminated copper dust ignites faster than dry dust. Fourth, sparks from grinders or tool contact easily ignite airborne clouds. Fifth, copper oxide layers heat up during rapid oxidation. The smaller the particle, the higher the combustion potential. Physical behavior of copper dust in airflow. From an engineering perspective, copper dust behaves like a dense, conductive aerosol. First, coarse particles settle out quickly in low-velocity ducts. Second, the fine fraction stays airborne like a metallic fog. Third, copper dust is highly abrasive to elbows, fans, and dampers. Fourth, conductive particles cling to magnetic or steel surfaces. Fifth, copper oxides pack tightly deep inside filter media. For copper dust, I designed duct velocities from 4,500 to 6,000 feet per minute. Filtration equipment that works best. FOA and cartridge collectors. Great for fine airborne copper dust. First, high-efficiency membrane media captures sub-micron particles. Second, conductive filter media prevents static and spark hazards. Third, strong pulse cleaning removes dense copper oxide. Baghouse Blizzard, best for heavy grinding and polishing loads. First, rugged bags handle high dust volumes. Second, large chambers keep airflow stable. Third, inlet baffles protect filters from direct impact. Specialty requirements. Copper dust often requires, first, anti-static filter media. Second, conductive ductwork only, no plastic ducting. Third, abrasion-resistant inlet zones. OSHA and NFPA compliance copper dust falls under OSHA first, general duty clause for combustible dust hazards. Second, exposure limits for copper fumes and copper oxide. Third, hazard communication and required DHAs. NFPA 484, combustible metal standard. For copper dust, NFPA requires first, explosion venting when dust meets combustible criteria. Second, duct isolation valves to stop flame propagation. Third, full grounding and bonding of all metal ducts. Fourth, anti-static media throughout the dust collection system. Fifth, strict elimination of ignition sources near copper dust operations. Compliance is non-negotiable for safe operation. Capture hood design for copper dust. Workstations. Copper dust spreads quickly, so proper capture design is essential. I install first, fully enclosed grinding and buffing hoods. Second, downdraft or side draft tables for polishing. Third, high static fume arms for manual grinding. Fourth, enclosed CNC machine extraction. Fifth, capture points at tumblers, vibratory finishers, and deburring wheels. Good capture prevents heavy copper dust from entering your ductwork in the first place. Copper dust may look like a simple reddish-brown powder, but it is conductive, reactive, abrasive, and in fine form, capable of ignition and rapid oxidation under NFPA 484 conditions. With strong airflow, high-efficiency filtration, conductive ducting, and full OSHA and NFPA compliance, we can manage copper dust safely and reliably while protecting both workers and equipment. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, copper belongs in your cables, not floating in your facility. See you in the next video.